Hello, my name is Sarah Herzog, and today I'm going to be showing you how to create a player health system in Unity and to create a hazard that will damage your player and display that health on the screen in some way. So this is part one of a 5-part tutorial. And in this part, I will show you how to do the very basics of that. It will be a one-hit KO system, one-hit kill. And your player will die in one hit, your enemy will kill your player instantly, and there will be no visible health displayed for this part of the tutorial. So this health system is intended for your player, but it can be extended. The same logic can be used for enemy health systems, and I may show this in a later tutorial as well. This tutorial will not include any kind of enemy behavior, such as movement or attacking, and it will not include player attacks. I will be covering those in a later tutorial. So yeah, as I said, this part will be the one-hit KO version, and we will then extend that in the next part of the tutorial to include health and more things. Even if you plan to eventually have health and damage values, you should start with this tutorial because my next section will build on this to get the health and damage values. So what do you need to know or have set up already in order to do this tutorial? You need to have Unity installed, you need to have a Unity project created for your game, and you need to have at least an image asset for your player and an image asset for your hazard. Now this tutorial will be done with 2D in mind, but you can apply the exact same logic for 3D. You will also need to be able to move your player in some way. So I just suggest you looking at one of my other tutorials to learn how to do player movement. In my game that I will be using as an example, I am using a mobile style on-screen controls for moving the player, but you may have arrow keys or whatever else you want to do to move your player. Okay, so here's the plan. When I do tutorials, I like to talk about programming in terms of conditions and actions, like Lego blocks that you can put together. And this is still true in this tutorial, but it is a little bit more complicated because we're going to be working with 2 separate scripts this time, and they're going to need to talk to each other. So the condition for our one-hit kill part of the tutorial is when a collision happens, and then the action that will happen based on that condition is destroy the player object. So when the player collides with the enemy, destroy the player object. Now, we could do this all in one script. We're not going to, and the reason for that is that later on, we really will need to have 2. And that's because the player really needs to be the one that's responsible for how much health they have, but the hazard or enemy will be the one responsible for how much damage it deals. Now I know we're doing one-hit kill for this portion of the tutorial, but we're trying to design with this with our future version of the tutorial in mind. So we will be starting right off the bat with 2 separate scripts, one for our player and one for the hazard. Okay, so the player will then have the destroy an object part of our plan, which is the action, and the hazard will have the when a collision happens part of the plan, which is the condition. And we'll need to make them communicate using a function. So this is ideal for a beginner who may not have heard about functions before, and I will explain how you write your own custom function and how you call your own custom function using Unity's code. So the first thing we're going to need to do is actually create a script to use for our player health. So in your project, I want you to find your scripts folder. If you don't already have a scripts folder, you should be keeping all of your scripts tidily in their own folders so they are not making a huge mess in your general assets root folder. You don't want to just have all your assets mixed together. You need to organize them. Now, I already have some scripts in my folder that I was using for player movement, but we're going to add a new one. So I'm going to right-click my scripts folder. I'm going to go to Create, and I'm going to choose C# script. And remember, when you first create a script, do not hit enter or touch anything else. You need to rename your script right here because this will also change some text inside the file but if you rename it later, that text won't be updated and it will cause problems for you. So make sure you name your script right away. And I'm going to name mine Player Health. And remember to use the convention of capital first letter for all words. So player and health are two separate words. I'm going to capitalize the P and the H. The rest of the letters will be lowercase, but no spaces. That's very important. If you have a space in your script, it will break the script name. So you must make sure you do not have any spaces. You just leave them, the words connected. And if you have a capital letter for that second word, it's still very easily readable. So player health. Okay, so I have a brand new script. I'm going to go ahead and open it up by double clicking it. And this will open Visual Studio or whatever editor you happen to have set up for Unity. Mine is Visual Studio. Okay, I'm going to close the other script I happen to have open there. So you can see Player Health now has some code already in it. And this is just what Unity does. It will always have some code already in your script whenever you start. So what you want to do from there is we are going to actually get rid of the start and update functions. We're not going to be using them. Okay, so get rid of those. Make sure you still have your Player Health open and close curly brackets. These curly brackets keep your player, they tell the computer, they tell Unity what code is inside your Player Health script. So you can see here it says public class player health :mono behavior. We need to make sure we keep these curly brackets because they tell Unity that everything inside those curly brackets is part of our player health script. So we need the curly brackets. Okay, we are going to, in here, define our own custom function. So up until now, we've used built-in Unity functions like update and start and on collision enter, things like that. But in this case, we are going to build our own custom function. And it's very easy to do. It's the same way that you would write another function, right? So if I had left this as it is, we can see that there's some functions already in there. This is how it used to be with, void, a function name, these parentheses, and then curly brackets. That's how you make a function. So we're going to make a function called kill. So we're going to start off the word void, just as we had in those other example functions, and I'll explain again why we use the word void in a moment. We're going to use the word kill with a capital K. Functions should have the first letter capitalized. We'll use these parentheses to indicate it is a function. That's what those parentheses mean, so you need them. And then we'll have our curly brackets, and everything inside these curly brackets is part of this function. So that's how Unity knows what part of the code should be part of the function kill. So the way a function works is that whenever this function is called or activated or run, when this function is run, everything inside those curly braces executes. Everything inside the curly braces will run. So any code that is inside there will happen whenever this function is called. So we can call this function manually elsewhere in our code, and that's what we're going to do. It's essentially like a shortcut to run some code. All right, so we have this kill function. Now let's briefly talk about what this void means. The void is a return type, and void means that there isn't a return type. That means there's no extra information being given back to whatever code ran this function. So if in a different place in our code, we say run the kill function, if we had a return type, that would then give back to that code some extra information, but we don't need any here. So we're going to leave it as void. What we do need at the beginning of this is the word public. And this is something new. We haven't seen this on the built-in functions by default. And what public means is that it will allow me to call this function from a different part of my code. But I have to have the word public there to make it available to the other script that we're going to make. Okay, so we're going to have a hazard script that's going to call this function, but the function has to be marked as public so that hazard script can handle it. Okay, so let's give ourselves some notes here so that we remember what this all means. Remember that you can use comments to give yourselves notes, and comments are done with 2 forward slashes. Okay, so we'll say this function is not built into Unity. It will only be called manually by our own code. So start and update, those are called automatically by Unity at different points in the game's lifetime. But this function is custom. It is something that we made up. And we can name functions whatever we want. We can make as many functions as we want, but they will not run unless we have manually told them to run. So right now we're defining a function. It's kind of like if you wrote down a recipe on how to bake some bread. If you wrote that recipe down, it won't automatically bake the bread. Like, I wish that was how the world worked, but it doesn't. You still have to go execute that recipe at some point. So we're writing down the recipe, as it were, here. We still need to actually execute that recipe to make it happen at a later time. Okay? So just a note also, it must be marked public so our other scripts can access it. And I missed a close quote there. So that is why we need that public on there. Okay, so what does this script actually do? What does this function actually do? Nothing at the moment. There's nothing inside there. But this is our action that we want our game to take. And as we talked about in our kind of plan at the beginning of this video, we really want this to destroy our player. That's what kill should do. Kill should destroy the player. So in a later video, I will explain how to make this do something a bit more user-friendly. So it might take you to a game over screen with a button to let you reset, or if you might have a lives system in and you can subtract a life and restart the current level with less lives. Right, that is something we'll talk about in a future video. For now, we'll do something that's a little bit janky, and we will just destroy the player's game object. So you won't be able to control the player anymore. They'll just be gone. And that's a good sort of starting point for this, for just testing it out to see if it works. And we can expand on that in the future. So let's say this will destroy the game object that this script is attached to. And how do we do that? We use the destroy function. This is a built-in function to Unity that we are now calling. So we're not writing a function, we are calling a function in Unity. And the function is called destroy. And this function, if you notice, my Visual Studio has very helpfully popped up some information, and it's saying it wants me to provide an object that will be destroyed. So we're going to destroy lowercase g game object, no spaces. So game object is a variable that is built in to every script, and game object allows us to access the game object that our script is currently attached to. So this script is player health. You might guess, therefore, it is attached to the player. So we are going to destroy the thing the script is attached to, that is the player, and we have accomplished our goal. Now, we also need to make sure that we put a semicolon at the end of this line of code, because a semicolon, remember, in coding is like a full stop or period. Okay, that's all that script needs to do. It's very simple script. We'll be expanding on it later, but for now, that's all it needs to do. All right, so now we need to save this script. Make sure you save it. If you don't save your scripts, it will not show up properly in Unity. You can tell it needs to be saved. I'll go ahead and make a change here. You can tell it needs to be saved if you see the little star in the top right. It's a bit hard to see that on my screen because of my border on my video, but there is a little star up on the tab for that script. There'll be a little star there, and as soon as you save, the star will go away. Okay, let's move back to Unity now that your script is saved. Okay, so in Unity, we need to take our player object. Now, you should already have a player object because I said at the beginning of this video, in order for this video to work, you need to have a player that already has movement set up on them. So you should have a player object in your screen already. So I'm going to click on my player here, and I'm going to add my script to it. And remember, you can add a script by either dragging the script onto the player from your scripts folder. So I can take player health and drag that onto the player, Or you can also go to add component, type in player, and you'll see player health show up. Don't add it both ways because then you'll end up with two scripts and that will be very confusing. Don't do that. Just one is enough. Okay, so player health is now on our player. Now, this is a function that doesn't do anything on its own. Just like we've talked about with conditions and actions. Actions don't happen on their own. Conditions don't do anything on their own. They have to be combined. So right now we have a function that has not been called. That is essentially an action that has not been triggered by a condition. So we need to actually trigger this action to happen. And as we discussed in our plan, that's going to be done through our hazard. So we need to create the hazard before we can do anything else. Let's go ahead and drag our hazard into the scene to make a game object out of it. I have a spike for my hazard. You may have a static hazard like a spike, or you may have lava as an environmental hazard, or you may have something like an enemy, and you can add movement to it later on and just use the enemy as a static hazard for now. So I'm going to use this spike. I'm going to drag it into the scene and just drop it here underneath my player. It doesn't really matter exactly where it is. I just don't want to put it right on top of my player because we're going to have to move the player to show it only does damage when you run into it. Okay, so now I've got this spike. So we're going to be creating for this spike a hazard script. So let's go ahead and go down to our scripts folder again in Unity, right click on scripts, go to create, choose C# script, and this time type in the word hazard. That will be our name of our new script. And make sure to use a capital H, no spaces, no special characters. Okay, and then open the script once you've created it. Okay, here's our new hazard script. We're going to go ahead and again remove our unneeded functions here, the start and update. Okay, and we're going to use a built-in Unity function. So that function is going to be the onCollisionEnter2D function. Okay, so this is very important because it is a built-in Unity function. You must make sure that your code matches exactly. Now, I've noticed here that my Unity has decided not to correctly use its syntax highlighting, its library here. It doesn't actually know what a mono behavior is. It's not kind of working properly. If that ever happens to you, you can always close Visual Studio and reopen it, which is what I'm doing just now. And usually it fixes the problem. So your mono behavior really should be a different color. You see my mono behavior is now green instead of white. That shows that the Unity syntax highlighting is working correctly in Visual Studio. It may seem a little technical to you, and if you don't notice it happening, then it's not a problem for you. But if you do notice it and it's a problem, then go ahead and just try closing Visual Studio and reopening it to deal with that situation. Okay, so as I was saying before we got a bit distracted by Visual Studio misbehaving, what we need to do now is create a onCollision2D, an onCollisionEnter2D function. And the spelling and capitalization and everything is vital that you get it correct. Because if you don't spell it the exact same way that Unity is expecting, then Unity will not call your function. It will think that you have defined a new custom function, and it doesn't know about the custom function, so it won't call that function. So you must spell it exactly right. So the way you do that, it's going to be void, and then onCollisionEnter2D. Okay, double check that you've got that correct. Then, inside your parentheses, this function has a variable that's being passed to it. It's called a parameter to the function. So that function, that parameter is a collision2D, and we're going to call it collision data. And not collision data, Sarah. Collision data. So this is a function built into Unity, and it must have exactly this parameter and exactly this name. The name of the parameter doesn't matter so much, but the type has to be the same, and the name of the function has to be the same. So let's give a note here to remind ourselves. This is a built-in Unity function for handling collisions. This function will be called when another object bumps into the one this script is attached to, which in this case is going to be our hazard, our spikes. Okay, so when a object bumps into the spikes, then this function will be called. Okay, so far so good. I think it's pretty clear. So now we need to figure out what to do. So this is basically our condition, right? Well, not quite, because our condition isn't when any object runs into a spike. It's when the player runs into a spike. What you don't usually want is your enemies damaging each other when they bump into each other. Now, you may wish to add that to a game, but for now, we're going to go under the assumption that you do not want to damage other enemies. You only want to damage the player. Okay? So in order to do that, we need to check if the thing we bumped into is in fact the player. So let's do that. First of all, we need to get the information about the thing we bumped into. So that's our plan here. Get the object we collided with. And we're going to get that as a collider, because anything that we had a collision with, we know for a fact will have a collider. And we can get that collider, and we're going to store it in a variable called object we collided with. Okay, this is just, you can name it whatever you like, but it should be explaining what you're doing. So I'm calling mine object we collided with. This is a variable I've declared, and we're storing it inside a collider2D type variable. So this is saying make a variable called a collider that is a collider2D type, and it will be called object we collided with. And then into that variable we will put, that's what the equal sign means. It means put something into the variable. Into the variable, put, and we're going to go to our collision data, and that is the variable we've been given from our function. When something calls this function, it will give it this collision data. So we're going to go to collision data dot collider. So this is something that is in this collision data. So dot means go to that thing and get it. So what we're going to do here is we're getting this collider from our collision data, then storing that collider into this newly created variable. Okay. Once we've done that part, we're then going to get the player health script attached to that object, if there is one. This is how we know if this object is our player. If it has a player health script, it's our player. If it doesn't have a player health script, it's not our player. So how do we do that? Well, first we'll create a variable, player health, player. This is a variable called player that will contain a player health object. That's what this syntax means. And then we're going to assign to that player a value. So we're going to assign object we collided with dot, which means go to that object. And we're going to call a function here, getComponent. And this function is called in a little bit of a special way. Instead of putting information into the parentheses, we're going to use these funky angle brackets, greater than, less than symbols. Okay, so object we collided with dot getComponent, angle bracket, and then inside there we put player health. That's the type of component we want to get. So we are going to get the player health component from the object we collided with. And then we use parentheses afterwards and a semicolon at the very end. So this entire line of code says create a variable called player, and into that variable put in the player health component that is attached to the object that we collided with. That's what this line of code says. Okay, well now we need to check if that actually worked. Because if it worked, it means that was our player, and we need to then kill the player. And if it didn't work, that means that it wasn't our player and we shouldn't do anything. So we're going to do that with an if statement. And it's very simple. We're going to say if player is not equal to null. Okay, so what does that mean? Well, this fancy exclamation point equals means not equal. And this is saying null in computer speak means nothing or empty. So if the player variable that we just created and assigned something into, if that player variable is not empty, then do some stuff. If it is empty, we will skip doing the stuff and we will just end. Okay, so let's put a note here. Check if we actually found a player health script on the object we collided with. This if statement is true if the player variable is not null, aka empty, right? If it is not empty. Okay, so if it is not empty, this means there was a player health script attached to the object we bumped into, which means this object is indeed player. So then we need to therefore perform our action. We've been waiting to play to perform this entire time. Okay, so how do we perform that action? Well, we're going to call a function on the player. Because remember, that's what we did earlier on our player health script. We created this kill function. So let's say player dot kill. That's how we call a function on a script that we wrote. We first need a variable containing that script, and then we need to just do dot, which means go to that thing, and then you just use the function's name and then parentheses afterwards to call the function. Okay, so we're saying, hey, on this player we bumped into, use the kill script, and the player will then go and run this information and it will destroy the player. Okay, so that is how we go about doing this. Make sure you save your hazard. And we will now go back to Unity. So let's go back to Unity now. Our hazard has been saved. And I'm going to click on my spike here. And I'm going to now attach this hazard to the spike. And remember, you can do that by dragging your script onto the spike, or you can use add component. So my spike now has a hazard. Now, if I were to run the game right now, nothing will happen when I bump into this spike. And there's a reason for that. So if I press play here and I move downward, nothing happens when I run into the spike. And that's because in order for a collision to occur, both the player and the spike need to have a collider. So if you've been setting up your player already, your player may already have a collider. If they don't, you'll need to add one now. I'm going to add one to my player at the moment. Now remember, if you're using 2D, you need to make sure that all of your colliders are 2D colliders. So in the code, I used a 2D collision code. I'll show you that now. In the code here, we used on collision enter 2D. So if you're using 2D, you must make sure the colliders that you attach to your player and to the spike are actually 2D colliders, because Unity has 3D colliders, and unfortunately they are completely incompatible with the 2D versions. They're like different dimensions. You can't handle them, right? So they can't go together. You must have only one or the other. So in our case here, we have our 2D collision code, so that our in-game stuff must be 2D as well. If you are working in 3D, make sure you remove the 2D section from this bit of code, and then in Unity, you can use your 3D colliders. Okay, so I'm going to add colliders to my player. I'm just going to use box colliders because they're nice and simple and they're suitable for this purpose. And the same thing on the spike, I'm actually going to use a circle collider because my spike is very circular. Your mileage may vary. You can use whatever kind of collider you want. So now I can see I've got colliders on both my spike and my player. If I click on the player, you can see that green outline. If I click on the spike, you can see green outline. That's the collider. Okay, now if I press play and I move my player towards the collision, they just die. And that's exactly what we wanted to do. One hit KO accomplished. Okay, now yours may not have worked perfectly the first try. You may have issues. So here's things you want to check. First, if your game, if it's not working, or maybe you can't even actually press play, you may have error messages. check in your console window down here and see what the error messages are. A lot of times they will tell you exactly the line where the issue happened. So you don't have to do this. Please don't do this. If yours is working properly, I'm going to go ahead and make an error in mine so you can see exactly what will happen, right? If I remove this semicolon and I save it and I go back to Unity, I will no longer be able to run the game. And that's because all compile errors must be fixed before I can run the game. And you can see in my console window, there's a compile error. It says assets, scripts, hazard.cs, and some numbers. That's telling me the line number and the character number. Error, CS1002, semicolon expected. Okay, so that's actually telling me exactly what's wrong and what line it's wrong on. But it's a little bit intimidating when you're first starting out. My advice is to simply very carefully read the line, and you can actually double click on it it will take you into your code to the line where the problem is. And you can see in Visual Studio, there's a squiggly red line there. And if I mouse over, it says semicolon expected. So it tells me exactly what the error is and where it is. And you could just put back in your semicolon in this case, and that will fix that error. You may also have errors that come up during the gameplay, and if that happens, again, read them very carefully, try to understand what they mean, and check the line of code where the problem is occurring. If you aren't having any errors, but it's still not working, make sure you've actually attached both of your scripts, make sure that they both have a collider, and make sure that they're all 2D colliders, and double check the spelling of your functions in the script itself, because maybe that's not getting called. Okay, so hopefully by this point you will have a fully working one-hit KO system for your player. The next steps, well, first of all, if this is all you wanted, if you want your player to die instantly, then you're basically done with your player health system at this point. If you want to add numerical values to your player health, then listen to the second video in this series, which will explain how to add numerical health values. And there will be more later on that will then explain how to add either text display, icon display, or bar display for that health as well. Later on, I will then eventually be adding video tutorials that will cover topics like enemy and player attacks, but that is not going to be in this particular series of tutorials. Okay, so thank you for watching. If you enjoyed this video, if it helped you out, please give it a like, consider subscribing. And if you have questions, you need help with something, just ask in the comments and I'll do my best to give you a hand. Thank you for watching. Bye.